In this module, we're going to see bond pricing advanced. We're going to see the difference between the clean and the dirty price. We're going to see how accrued interests affect and intervene in the dirty price. We're going to see the pricing of bond when only one coupon is left to pay. And we're going to see the pricing in non-coupon dates. The quoted price is equal to the flat price or clean price. The price we have computed so far is the full price. This is the one we have computed. We haven't computed any other price yet. So we have computed the full price, and then this full price we have to take off something that it's called accrued interests. And now we're going to see, well, this is the formula. So let's try to see in detail where this formula comes from. The important thing here is that there's going to be a coupon. It's going to be paid at t equals 1. So what I'm going to do is this triangle to be able to understand what's going on. So here I'm going to receive the full coupon. So let's write it the same way that it was written before. So here I'm going to receive 100 times c in percent over 2. And then from t equals 0 up to t equals 1, then the coupon, so this would be equal 0, this would be t equal 1. So here I'm going to receive the full coupon. So I'm going to receive the 100 over c and a half. But if I'm somewhere in the middle, like at t equals today, then I'm going to have to receive less than that. And the question is, all right, how much less? And this quantity here is going to be called accrued interests. So what we know is that in this part of the graph, we have the number of days. It's going to be equal to n last settlement. In the whole period, we're going to have, so it's all this, we're going to have n last to next. Hence, if we do some mathematical proportions, then we have that accrued interests. So this side over this side, NLS, it's going to be equal to this big side over the big side here. So it's going to be equal to 100 c and a half over NLN. Hence, we can find that accrued interest is equal to 100 c and a half NLS over NLN. So this would be the formula for the accrued interest. And what does it mean? That basically this accrued interest is something that do not correspond to the buyer of the bond. Why? Well, because the buyer of the bond is arriving late to buy this bond. Hence, all this part here, all these dates corresponds to the seller of the bond. So that means that finally the bond price, I need to subtract the accrued interests to find the clean price or the quoted price as it's called. Now we're going to compute the bond price, which in this case is going to be the same thing than the quoted price, which is going to be equal to the dirty price minus accrued interest. So from before we had computed the dirty price. So it was this value, the 96.42 when we computed it for t equals today. And now we need to subtract the accrued interests. So we know that accrued interests are equal to the coupon. In this case, it's going to be like 10% over 2 times 100. So that's 5 times. So this is settlement to next. And we need last to settlement. So it's going to be the 147 over 182. So this one is 182 minus 35. And then from here, we're going to get 4.038. So these are going to be the accrued interests. That's the part that does not correspond to the buyer of the bond. It corresponds to the seller. Hence, the clean price or the quoted price should not include this value. So we take the dirty price, the 96.042, we subtract the accrued interest, and we get quoted price. Now, the second thing is bond prices are quoted like this. So if you go and look online for the bond over price, you're going to see it's 92-15. Know that what it means is that the price is going to be equal to 92 plus 15 over 32, basically 19.47. So be careful not to think that 92-15, so this is different than 92.15. It's not this, okay? It's not, there's not a dot. Finally, when there's only one coupon left, you don't apply the same formula. You apply a different formula, and the formula is down here. Let's look at an example. The example is as follows. So we go and take exactly the same bond. So it has a coupon 10%, yield 11%, time to maturity. So it's less than 6 months. NSN, it's 35 days, and NLN, it's 182 days. So in this case, you're going to replace 100 times 1 plus C.5, so it's going to be equal to 5 over 1 plus 5.5%, and then this times NSN 35 over 182. So this is how you compute the price. And then the answer you should find is that it's equal to 103.91. Some other type of bonds. So we also have US corporate. These are the ones that companies issue. We have municipal. That's basically the different entities like states and so on that issue bonds, and federal agencies can also issue bonds. Settlement in those bonds, normally it's 5 business days. Now there's some conventions about calendar. So one of the most popular conventions is this 30 over 360. And there you assume that every month has 30 days and that the year has 360 days. So in this case, for example, if you're between August 15 and October 20, then you're going to have exactly 2 times 30 from August 15 to October 15, plus the 5 days from October 15 to October 20. So in total, you're going to have 65 days. And in this case, NLN is always going to be equal to 180. Now note, some people are going to say, oh yeah, but August has 31 days. In this case, we don't care. Why? Well, because this convention tells us that all months are going to have 30 days, or are going to be assumed to have 30 days. February is going to have 30 days. January is going to have 30 days. All months are going to have 30 days in this convention. Well, other types of calendar counting are actual or actual. So in this case, you're going to count the exact number of days that there are between 2 dates. So for example, between here, like August and October, they're not going to be 65, but there might be. So August has 31 days, September has 30, so that's going to be an extra day. So in this case, the number of actual days would be 66. Another convention could also be business days over 252. So in business days, you would count just the business days, which is 5 days per week. So these are different day count conventions that can be included when or assumed when pricing a bond. More on US Treasury securities. As we saw before, the world's largest borrower is the US, 26 trillion, and compare that to like the 3 trillion that they had 15 years ago. There's other types of securities. So the T-bills, that's equivalent to CETES. These are short-term maturity, and there's no coupon in these instruments. There's the T-notes, treasury notes, that's a name, basically. That's the securities or the bonds that go from 1 to 10 years. And then we have the treasury bonds. Those ones go from 10 years to 30 years. The last two pay semi-annual coupons. There's another type of bond called the TIP. It was introduced in 1997, and that's basically a bond that protects against inflation. So the principal is adjusted for inflation every 6 months, and it's about 10% of the market in the US. Another concept is the concept of underrun versus off-the-run bonds. So underrun is basically the bond that has most recently been issued. So let's say you have a 30-year maturity issued today, and then 6 months go by. So when 6 months go by, the government issues a new bond. So once they issue that new bond, they're going to issue this 30-year bond, and then you're going to be left with another bond that is 29.5 years to maturity. So this bond here, it's called underrun, and the one below, it's called off the run. So you end up having a lot of off the run bonds and a lot of the on the run. Important thing to know is that on the run bonds are way more liquid than off the run. So some arbitrage opportunities can exist there, and this is what long-term capital management did in the 90s. They tried to exploit those differences in the price, because when you think about it, these two bonds, they should have fairly similar prices. And then at maturity, you know that the two of them are going to pay 100. So they should have the same price. But in reality, they do not, because the off the run are less liquid. And because of the difference in liquidity, they have different prices. So that means that you can play with that difference in price to make money.